Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you about the graphical method which is used to identify the order of reaction. Okay. So here in this method, how we are going to find the order of reaction? First, we draw the graph between the rate of reaction and concentration, and half-life and initial concentration. We are going to draw the graphs. So by using that graphs, we are going to find out order of reaction. Okay. So we know for zero order reactions, for zero order reactions, zero order reactions. So what is a zero order reaction? We know that is dx by dt. Dx by dt is equal to k into concentration to the power 0. So this is called what? Zero order reaction. So in this zero order reaction, when you draw a graph between dx by dt concentration, dx by dt, when you draw a graph between okay, so when you draw the graph here between dx by dt, dx by dt, it is nothing but rate. It is rate of reaction. It is rate of reaction, and here I am going to take the concentration. Concentration we can take as A minus X or A. Okay. So when you draw the graph between the rate of reaction and concentration, here rate of reaction does not depend on what? Initial concentration. Rate of reaction does not depend on initial concentration. So we get such type of curve. Okay. Now when you get this type of curve, rate versus concentration, it will become what? Zero order reaction. Next, first order reaction. First order reaction. Okay. Next, first order reaction. First order reaction. So in first order reaction, how we will get the graph? So we know in first order reaction, dx by dt is equal to k into a minus x power 1. So when you plot a graph here, when you plot a graph, when you plot a graph between rate of reaction, that is dx by dt versus concentration, that is a minus x, a minus x, or you can take a, or else you can take concentration. Okay. So how will get the graph here? See, d by dx is directly proportional to what? A minus x. So here, like this graph we are going to get. Okay. So they are directly related, which means children, in first order reaction, concentration increases, rate of reaction is also increases, whereas in zero order reaction, how much concentration increase also, rate of reaction not at all going to be changed. Okay. Next, second order reactions. Second order reactions. So in second order reactions, how we are going to get the graphs between the rate of reaction and concentration? We know dx by dt, this is the rate of reaction. Dx by dt is nothing but rate of reaction, change in concentration by time, that is equal to k into a minus x whole square. So now when you plot a graph here, when you plot a graph between rate dx by dt versus a minus x whole square. So here a minus x concentration whole square is directly proportional to what? Dx by dt. So where k is the constant. Okay, so here this type of graph you will get, or else you can draw one more graph also here. Okay, so if you draw the graph between dx by dt versus a minus x, instead of a minus x whole square I am going to take a minus x. So you will get a graph curve like this. Okay, not that much. Okay, so a hyperbola you will get like this curve you will get. So this indicates, this graph indicates what, children? Second order reaction. Okay, so here this graph is in between dx by dt means rate of reaction versus a minus x whole square. So a straight line you will get through the origin, and dx by dt a minus x, a hyperbola curve you will get in the second order reaction. Okay, next you see nth order reactions, or directly go to the nth order reactions. So in nth order reactions, how we can take the graph, or else first you see the third order reaction, later we'll discuss about the nth order reaction. Okay, nth order, before the nth order you see the third order reactions. Third order reactions, dx by dt is equal to k into a minus x whole cube. So which means, children, here how we will get the graph? When you draw the graph between, dx by dt is the rate of reaction, and a minus x whole cube. A minus x whole cube means a change in concentration. Dx by dt, how they are related? Directly proportional. Means a minus x whole cube increases, rate of reaction also increases. Or else you can draw one more graph here for this. So that is dx by dt a minus x. Okay, how will get curve here? Here hyperbola like this. Still it moves towards what? Y axis. Towards y axis means concentration increases rapidly. The rate of reaction is also increases. Okay, right. Next, nth order. So simply nth order. For nth order, how will write the graphs? Dx by dt is equal to k into a minus x. Here a minus x whole power n. This is known as what? Nth order reaction. So in this nth order reaction, how will get the graph here? So here generally we draw graph between the rate of reaction dx by dt versus a minus x whole power n. So directly straight line we will get through the origin. Okay, so this is about the graphical method by using the differential rate equation, and we can draw the graphs between the t half and initial concentration also, t half versus initial concentration. Okay, now let us see, we know what is the half life. T half. What is the T half, children? T half means time required to complete the half of initial concentration. So here T half is nothing but time required to complete half of initial concentration, half of initial concentration, half of initial concentration, that is called half life of a reaction. Okay, so now here we are going to draw the graphs between T half versus initial concentration. We know T half and this is the relation between the T half and initial concentration. T half is proportional to 1 by a power n minus 1, or T half for any reaction. T half is proportional to a power 1 minus n. Okay, so this is the relation we know already. So now we are going to draw the graphs between T half versus initial concentration. Okay, so now how we are going to get these graphs, children? See, okay, for example, for zero order reactions, T half versus initial concentrations. Okay, T half versus initial concentration graphs. Okay, so the first one is zero order reactions. Zero order reactions. So in zero order reactions, here n is equal to 0. So therefore T half is proportional to 1 by a power n minus 1, or that is equal to, or that is implies T half is proportional to a power 1. See, simply here what we are substituting, or what we are doing, we are substituting 0 here. 0 minus 1, a power minus 1, a power minus 1 goes to the numerator, a power 1. Means T half is directly proportional to initial concentration in zero order reactions. Okay, so now let us draw the graph here. Let us draw the graph, okay, between T half versus initial concentration. T half and A. How the T half and A are? They are directly proportional. T half means initial concentration increases, T half also increases in the zero order reactions. Next, you take the first order reaction. First order reactions. So in first order reactions, what happens? So in first order reaction, again you take the relation T 1 by 2 is proportional to 1 by a power n minus 1. That implies T half proportional to 1 by a power, in place of n, what we write? First order reaction means n is equal to 1. Here 1 minus 1, that equal to 0. So that implies T half is proportional to 1 in first order reaction. Means there is no initial concentration term in the first order half life. Means T half of the first order reaction does not depend on the initial concentration. Okay, so when you plot a graph here, between T half and initial concentration, T half does not depend on the initial concentration in the first order reactions. Okay, next is the second order reactions. Okay, go to the second order reactions. Second order reaction. So in second order reactions, we know n is equal to 2. So T half proportional to 1 by a power n minus 1. 1 by a power n minus 1. Okay, so that implies T half is proportional to 1 by a power 2 minus 1. That implies T half proportional to 1 by a. Means T half is inversely proportional to initial concentration in which order reactions? Second order reactions. So how will you get the graph here? When you plot a graph, okay. So here we can show the two type of graphs here. That is, the first one is between T half versus 1 by A. So T half and 1 by A, how they are related? Directly they are related. We can get this type of graph. Or else you draw the graph between the T half and A. T half and A, how they are related? Inversely proportional. T half and 1 by A are directly proportional. T half and A, how they are proportional? T half and A inversely proportional. So like this, we will get the graphs in second order reactions. Okay. Next, in third order reactions. In third order, what is the meaning of third order here? N is equal to 3. If N equal to 3, that is called third order reaction. So here T half proportional to 1 by A power N minus 1, that implies T half proportional to 1 by A power minus 3 1, that implies T half proportional to 1 by A square. Means T half is inversely proportional to square of initial concentration. See, initial concentration increases, T half decreases. Where? In the second order reactions. Okay, T half and initial concentration, how they are related? Inversely proportional, square of initial concentration. Okay, now let us draw the graphs here. Okay. Okay, right. This is T half versus 1 by A square. T half versus 1 by A square. T half and 1 by A square, how they are related? Directly proportional. Or T half versus A square, they are inversely proportional. Like this, we are going to get the graphs. So these are the graphical methods to find the order of reaction. Okay, which means we do the experiments and we draw the graphs between the T half and the initial concentrations. Okay, so we are going to get any one of these different type of graphs. So we are going to match that graphs with the different type of order of reactions. Okay, right. So this is what a graphical method. Next, Ostwald isolation method. So this is one of the very important method. So when we use Ostwald isolation method, so Ostwald isolation method generally used when we are having more than one reactant. When we are having, children, more than one reactant. If only one reactant is present, what we use? We use the want half differential method. But when we are having more than one reactant, Ostwald isolation method we are going to use. Okay, so this method is useful. This method is useful. This method is useful when we are having more than one reactant. We are having more than one reactant. We are having more than, when we are having what? More than one reactant, this method is very useful to find the order of reaction. Okay, so in this method, how we are going to find the order of reaction, means, children, see, let us take one example. A plus B plus C is gives rise to product. Okay, so now we know order of reaction with respect to A and B, rate of reaction with respect to A and B ABC, okay, rate is equal to K into A power M B power N C power O, like that we are going to take. So here what is the order here? What is the order here? We know sum of powers of concentration terms in the rate equation is called order of reaction. So here what are the powers? M plus N plus O. This will become the order of reaction. Means we are going to find the order with respect to A, order with respect to B, order with respect to C. So finally we are going to add them so that we will get what? Order of reaction. Okay. So how we find only M value? So when we are going to find the only M value, so here we are going to take the A concentration, B concentration and C concentration. So we do the several experiments like experiment 1, 2, 3, 4, like that we are going to take. So here in the experiment 1 we are going to take, let us consider A, B, C. A, B, C. So the concentration is 1 and here A concentration is 1, B concentration is 1, C concentration is 2. Okay. So what I done here, I kept the concentration of A and B is constant, but concentration of C I doubled. So now here in the experiment 1 rate I am going to consider R1, in the experiment 2 rate I am going to consider R2. Okay. So now what I will do, I will compare the R1 and R2. When I compare the R1 and R2, we will get the rate with respect to C. Okay. See how we are. And next in the next experiment what I will do, so I will keep the concentration of A constant 1 and it is 2 and it is also 2, like that I will take. Okay. So when you compare here, what I consider rate is R3. See, when I compare 2 and 3, concentration of A is constant and concentration of C is also constant, but concentration of B is doubled. So now if I compare the R2 and R3, I will get the rate with respect to B. And in the next experiment what I will do, here I will take the concentration 2 and here also concentration 2 and here also concentration 2 I am going to take. So when you observe here, this I am going to consider R4. Okay, R4 I am going to consider. Okay now. So now here what I am getting here, what you can observe, concentration of B and concentration of C is constant from experiment 3 in the experiment 3 and 4, but concentration of A only is changed. And I will compare now reaction 3 and reaction 4, means rate of reaction 3 and rate of reaction 4, so that I will get the order with respect to A also. So totally what I am going to do, I am going to add them so that I will get the total order of reaction. Okay, let us consider. So your rate with respect to R1 is consider 2 and here rate here you consider, okay, 4 you consider, and here R3 just consider 8 you consider, and here 16 you consider, like that. Okay, these are the hypothetical values only. Okay, so your rate is how much I am going to consider, 2 moles per liter second, and here R4 4 mole liter per second, and R3 8 mole liter per second, R4 16 mole per 16 moles liter per second, like that we are going to consider. Okay, so now you compare the R1 and R2, you will get the rate with respect to C. Okay, so now we know R1 is equal to what? K into A power X, sorry, A power M, B power N, C power O. Okay, so that is how much it is, rate of reaction is how much, rate is how much here, it is 2. And next R2 R2 is what? K into A power m, B power n and C power O. It is rate, here rate is what? How much? It is 4. Okay. So now consider 1 and 2. Okay. Do 2 by 1. Okay. What we are going to do here, children? 2 by 1. Okay. Next page we are going to do. Okay. Next page you will do. So do 2 by 1. So in the 2 by 1, in the 2 by 1 means R2 by R1. So here what is R2 rate of reaction to? So that implies what is the R2 and R1? R2 I take 4 and R1 it is 2. That is equal to K into 1 power 1A power M 1B power N and 2C power O by K into 1A power M 1B power N 1C power O. So here you observe K and K will get cancelled out. A power M, A power M, 1A power M, 1A power M will get cancelled out. 1B power M, 1B power N also will get cancelled out. And C also, okay. Okay, right. So now C also will get cancelled out. So what will get finally here? Here 4 by 2 is equal to 4 by 2 is equal to 2 by 1 whole power O. Why? Because here C and C also will get cancelled out. Why? Because powers are same. No, here 1C power O, 2C power O. Okay, right? So now this is not 0, it is O, it is. Okay. So now 2 by 4 by 2 means 2 power O. So here bases are same, so powers must be equal. Bases are equal means powers are also equal, means O is equal to 1. So means order with respect to C, order with respect to C is equal to 1. Okay. Next, so order with respect to C is equal to 1. Now we want order with respect to B. So how we can compare the order with respect to B? R2 and R3 we are going to compare. Okay. Now let us compare R3 and R4. Okay. So now let us compare here R3 by or R4 by R3. Sorry, R3 by R2. Okay. You compare R2 and R3 means R3 by R2 you do. R3 by R2. So here what is R3? K into 1A power M 2B power N 2C power O by K into 1A power M 1B, sorry, okay. One second. What is R3? Write 3 here. So here, okay, in R2 it is. It is 1B power N and 2C power O. So here R3 is what? What is R3? How much R3 value? R3 value is 8, R2 value 4, means 8 by 4. Okay, so here 8 by 4, that is equal to k will get cancelled out, 1a power m 1a power will get cancelled out, 2c power o 2c power o will get cancelled out. So here b also will get cancelled out. Here 2 power n, so here 4 ones are 4 twos are, means here 2 is equal to 2 power n. Here also bases are same, means powers are equal, therefore here n is equal to 1, which means order with respect to b, order with respect to b is equal to how much? 1. Next, so order with respect to a. So order with respect to a, where we can find order with respect to a? So by which equations, by comparing which equations we can get order with respect to a? So here where concentration of a is changed, 1 and 3 and 4. Here b concentration is constant, c concentration is also constant. Okay, so here rate is 8 and here rate is 16, means you compare R4 and R3. Okay, so you compare the R4 and R3. So compare R4 and R3. R4 by R3 is equal to k into 2a power m, 2b power n, 2c power o by k into 1a power m, 2b power n, 2c power o. Okay, so now here what is R4? 16 and R3 is 8. Okay, so that is equal to, here k will get cancelled out, a and a also will get cancelled out, 2b power n 2b power n will get cancelled out, 2c power o 2c power o will get cancelled out. So here what you get finally, okay, what you get finally, 2 power m. So 16 by 8 means it will be 2. 2 is equal to 2 power m. Therefore m is equal to 1. Means order with respect to a is also 1. So order with respect to m is also is equal to 1. Okay, therefore overall order is equal to m plus n plus o. So here m also 1, n also 1, o also 1. O also how much we got here? 1. Therefore total order is equal to 3, means it is the third order reaction. It is what, children? Which order reaction? It is a third order reaction. Okay, so now let us do one model problem over this. Okay, now let us go to the one model problem here. So which is asked in the JEE Mains. Okay, and given the real values here, not the hypothetical values. Okay, so for a reaction 2a plus b gives rise to c, the values of initial rate at a different reactant concentration are given below in the table. The rate law for the reaction is, we need to find the rate law for the reaction is. Okay, so here what is the rate law? So rate law is equal to, okay, so rate law, how we write rate of reaction? So rate is equal to k into a power m, or a power x, you like that you consider a power x and b power y. So this is the rate law, but here we need to find out the what is x and y values. Means indirectly here we need to find the order of reaction with respect to A and with respect to B, and we need to substitute that here. Okay, so now what we do here? So now you come here, concentration of A, concentration of B, and initial rate they have given. So now how we can find the x and y? First you observe this data. So from experiment 1 and experiment 2, when you observe, concentration of A is doubled, concentration of A is doubled, concentration of B is constant. So when the concentration of A is doubled, rate of reaction is also doubled. Okay, so direct like that also we can do, but simply if you do like that you may get confusion. First we will follow the process. In the next, while doing the remaining problems, simply I will give idea how to do it. Okay, so now here general method you follow, that is rate 1. Rate 1 is equal to k into a power x and b power y. A power x and b power y. So here what is the rate 1? 0.045, that is equal to k into 0.05 whole power x. It is also 0.05 whole power y. Okay, next rate 2. What is the rate 2? 0.090, that is equal to k into 0.10 power x. It is 0.05 whole power y. Okay, so this is the rate 1 and this is the rate 2. And rate 3, what is the rate 3? That is 0.0720, that is equal to k into 0.20 power x and 0.10 power y. That is what? Rate 3. Okay, so now we can find the we can find the x. How we can find the x? By comparing R1 and R2. So just do the R2 by R1. That implies, when you do so, what you will get? 0.090 by 0.045, that is equal to k into 0.10 power x, 0.05 power y by k into 0.05 power x, 0.05 power y. Okay, so now here 0.05 power y, 0.05 power y will get cancel out. Okay, so now here 0.05 ones are 0.05 twos are, means here 2 by 1, that is equal to, here k also will get cancel out. Here 0.10 by 0.05 power x. Okay, so 2 is equal to 2 power x. Therefore we know if powers are same, bases are same, means powers are equal. So therefore x is equal to 1, means order with respect to A is equal to 1. Next, order with respect to B. So this is see here, A concentration they are not kept any constant value. Okay, but here B concentration kept constant, and here they doubled in the third to fourth. So in the third to fourth only we can get the order with respect to B. Okay, so now what you do? R3 by R2. Okay, R3 by R2 you do. R3 by R2. So what is the R3 by R2? Okay, so R3 by R2 means here what you will get, that implies 0.0720 by 0.090. Okay, 0. See, it will be, okay, it will be 0.720, 0.720, it is 0.720 by 0.90, that is equal to so the data they given wrong. So okay, the data I took wrong. Okay, so here it is not 0.0720, 0.720. Okay, therefore now you do this problem, R3 by R2, that implies what is R3? 0.720 by 0.090, 0.090, that equal to 0.20 power x by 0.10 power x into 0.10 power y by 0.05 power y. Okay, so this is the data they have given. Okay, so now here when you see very clearly 0.720 by 90, we can write, you can write it as the 720 by 90, that is equal to, so here x value we know already. What is the x value, children? X is equal to 1, means it is 0.20 by 0.10 into, here it will become 0.2 power y, it will become 2 power y, it will become. Okay, so here 0 will get cancel out, 9 ones are 9 eights are. Okay, so here 8, that is equal to, here it is 2 into 2 power y, 2 into 2 power y. So this 2 you bring this side, so it will become 4 is equal to 2 power y. Therefore 2 square, that is equal to 2 power y. 2 square is equal to 2 power y. Just okay, right here we'll keep. Okay, so 4 is, so here what will get, here 2 square is equal to 2 power y. Therefore here y is equal to 2, means here x is equal to 1, y is equal to 2. Therefore this rate is equal to k into a power 1 b power 2. So this is asked in 2019. Okay, so like this we are going to solve these problems. Okay, right, sir. Okay, so this is about the question. Okay, right, so this is about this previous year question. Okay, thank you for watching.